We can see the presentation view, Victor.
Oh, okay, yeah. Yeah, sorry for the glitch. Yeah, so I was saying that maybe after that, the work for agentic deployments, it has already started, but that was not in like wide practice. 2025 is when it started in full swing. People started talking more about agents and how that can help. So agent is something like LLMs. Uh, they can produce some output, but agents are the ones which can take like autonomous actions. Yeah, while this is all powerful, like while agents can you can imagine something like maybe what example can I take? Maybe a flight booking app where an agent can like check the cheapest flights and it can book on behalf of the human itself. So there are like different kind of agents that we can imagine, and of course with the autonomy also comes the problem of security, right? Because with agents the threat landscape is going to it has increased, and for sure like we have to protect all the boundaries. Okay, so a very quick refresher of how LLM works. So LLM, we have like different components like user prompt, system prompts. User prompt is the one like that, the prompt that is given by the user itself. System prompt is something like set, that's set much before and defines how the model should behave. So once a user gives a prompt, so all the system prompt, user prompt, all that gets combined, and then it goes through something called as tokenizer, because tokenizer is something like it divides the sentences or words into like meaningful into a small subset actually. And then comes the embedding layer. Embedding layer is okay. The reason for that is that all these models like they understand only the numbers. So embedding layer, it's like a layer in between, which kind of translates the tokens into vectors that the model can understand. And yeah, so the embedding layer, it goes as input to the model, and then we get the output. I'm not going to it. And then we have another concept called RAG. Um, okay, so LLMs basically they are trained on internet data. So it means that they have something called as a knowledge cut of data. Let's say like if the LLM is trained on data before let's say May this year, then it means that it knows only about the information that happened before that date. So anything after that date, LLM will not be aware of it, or maybe anything that is proprietary, specific to a company which is not available on the internet, LLM will of course it will not be aware of it. So RAG is a method using which you can like uh, feed some documents so that the LLM now it starts to get the context from those fed documents, and its response now will depend on not just on the knowledge that it has learned, but it can also come from the documents that it has learned about using the RAG pipeline. So this is about RAG pipeline. Yeah. So at the worst, what can happen with LLMs and RAG? So the output may be unsafe. The output can be totally bogus, what the LLM says. Um, that can be one of the possible problems with the LLMs or the RAG model. Otherwise, the knowledge-based poisoning, the documents that was fed into the RAG pipeline, maybe that is containing some malicious instructions, or maybe some obscure instructions, which is like kind of hijacking the goal or something like that. So that is one kind of an attack that is possible. The other one is like indirect prompt injections. Like there can be some hidden instructions, or maybe like you're not the prompt as such. When we look at it, that may not look malicious, uh, but maybe a series of prompts, carefully crafted prompts, or maybe the hidden instructions, or maybe we also talk about steganography. Steganography, it's like a technique wherein like we can hide images, or maybe some hide images under a text. So this is like an there can be like an extensions to that, something like hiding instructions or hiding scripts under a benign looking text, something like that. The next one is the embedding inversion. Embedding inversion is something like when if we get access to a vector database or the embedding layer, um, which the LLM is using, then it is possible to like from the embedded from the vector, it's possible to like revert the actual text. So that's another kind of attack, but that can happen only if the attacker they get access to the embed that layer embedding layer or the vector database itself. I'm going to skip all these things. Yeah. So in short, we can say that LLM, they produce text. RAG, they generate plus retrieve based on the context that we fed. But agents, they can generate, decide, and then they can act. They can work like a feedback loop. Uh, they can produce certain action, and from the actions output itself, it can like again go back in a loop, and then it can like reiterate and make the output more and more refined. So this is like an architecture for agent. So now LLM, LLM is again a core component of agentic deployment, but now in addition to the models, it also has access to memory and tools that makes the agent so powerful. Now it can call tools like, for instance, agents can directly talk to your email and it can send emails on your behalf, or it can like directly go to your database, make some transactions. It can, or imagine it can like execute stock trading on your behalf. So these are some of the cool use cases that agent can do, and there are lot many creative things that the agent can do. So agents, they talk to tools using what we call using a protocol which has been standardized now, which is the MCP. And then no, there can also be like multiple agents talking to each other. So agents talk to communicate with each other through other protocol, which we call it as A2A, agent to agent protocol, and that's actually proposed by Google. Uh, Yeah, so the now if you look at the security aspects of it, now the agent has model, memory, tools, and then the permissions. So all of these combined together, it becomes a big attack surface. This is the multi-agent framework. Like this is an example of a multi-agent framework. So this can actually take several forms. Like we can have all the agents at the same hierarchy, or we can have like a hierarchical agents like this. So so generally, most of the use cases will have something called like an orchestrator agents. So this decides which is the appropriate agent to call for this particular task. So it can call the agents based on the user input, and then again, each agent can talk among itself as well. And we can also define like what tools each agent should have access to. So it's not necessarily like every agent should have access to all the tools. So that will actually create a lot of overhead. In fact, if there are like too many agents, there is a lot of overhead involved in like finding out the right agent and then the right tool call that needs to be invoked. So whenever we are designing an agentic framework, it is better if we can properly define what should be the scope of each agent, when it should be evoked, and in case of tools in a multi-agent framework, we can define like what are the tools that needs to be accessed by a specific agent. Not every tool needs to be accessed by a particular agent, right? So we can define all of these. Okay. So let's see, like as I was talking about, like there can be like multiple tools and agents can interact with all of these tools. So this generally happen using MCP protocol, and then I just want to like explain like what kind of the tools that we're talking about. It can be anything, like it can be from REST APIs to database to file systems to the applications like email. It can be anything, or it can be like simple code execution. So here I want to highlight. So previously we were using MCP for all the tool calls, But now that was creating a lot of overhead. Now we are talking more about skills. So skills, they are like you can imagine skills like detailed prompt. So whenever we talk to LLM, it's not that we'll get answer in a single shot, right? We will take multiple iterations. So based on all of that, we if we have to repeat the same thing multiple times, then what is the best thing to do is that based on the chat history, we can create a skill out of it, so that the next time when we want to repeat the same task, we can just call the skill. It skill is like a detailed prompt which has like all the instructions that are required to perform a particular task. Um, so now, yeah, instead of MCP, sometimes some of the calls, some of the tool executions, they can be done simply by invoking a CLI. So it is, if a CLI option is possible, then it is best to invoke a CLI rather than like invoking and making an MCP tool call. If the CLI is not possible, then it is better to use a skill or a command if when we are talking in a cloud context, because there we already have the detailed set of instructions that needs to be done. Maybe as part of a skill, we want to invoke an MCP tool. That is fine, but at least it has all the detailed steps. And maybe if all of this is not possible, then we can use MCP and make a tool call. Yeah, maybe I'll skip this in the interest of time. Okay, so OWASP is the Open Web Application Security Project. So it's non-profit organizations. So they were they were primarily previously they were working on like providing frameworks for web security. Now recently they have also started providing frameworks for LLM security and the agentic security, and they have defined like the different um, attack surfaces that are possible with agentic deployments. We'll talk about more of it in the subsequent slides. I'll skip some of these. Okay. I just want to briefly touch this. So whenever we talk about any attack, that will always have like different stages. One is like the attacker, they have to get some initial access into the system, and then not getting the access is sufficient. Sometimes they should, because they will not have enough privileges to do whatever they intend to do. So the next step is obviously privilege escalations. There are different ways to do it, and so after the step, then the attacker will be in a position to like run attacks. And the next step is the reconnaissance. Reconnaissance is a stage like wherein they probe the network and understand what's happening in the network. And the next stage is persistence. So it's like the ability of the attacker to dwell into the system so that he can continue to observe what is happening and then do a lateral movement and spread the attack to the different networks that are available in a particular deployment. And finally, they will, whatever objective they have, they'll try to do it. Maybe it can be data exfiltration, or it can be a ransomware kind of attacks wherein they kind of um, encrypt all the encrypt all the files in the system and then ask for a ransom. So this is a general in a general attack chain. This is what happens. Um, so this the person Skinner, he's a famous cryptographer. So what he has demonstrated is that with the agentic deployment, it is possible to do all of these stages autonomously just by the agents. So how scary it is. Imagine like previously it used to take like several weeks to months for each stages of attacks. Like maybe some very rarely we can an attacker can execute in a very short period of time. But now with the agentic deployment, all of this can be done within a matter of hours, or maybe the worst case it in a matter of days. So this is very scary if an attack like this can be completely autonomous, and if agents are operating at the machine scale, um, then of course human monitoring will not even scale here. We should also have agents which can work at the machine speed to kind of defend against these attacks. Otherwise, it's not possible to defend. Okay, now let's look up some of the attack techniques that are possible with the agentic deployment. So one is the memory poisoning kind of an attack. So here it can be like done in multiple ways. It can be sometimes a direct prompt injection, which is like very easy to solve, and sometimes it can be like indirect prompt injection. So this is like an attacker trying to like send some false data. So agent has access to memory. So it all the prompts that we feed into the agent, they get stored into the memory context that it has. So what happens is that over the time, if by using a carefully crafted prompt, the some attacker, they can actually change, they can manipulate the agent, and it can like hijack the agent's goal itself. So that is possible. The attacks like that is possible. So what happens after this? So once the agent's context is poisoned, and if that context is living in the long-term memory of the agent, that's even more dangerous, because all the subsequent prompts that have been fed into the agent, that will now look up at the poisoned context, and then each time the influence of that context will be reinforced more and more, and finally that will look like a cascading failure. So if we have to define the agents into like different classes, the first one is the input layer. That's like the layer where the input is fed into an agent. So that can be like a prompt, and then the goal hijacking that we talked about. The next one is the execution layer. The execution layer is when the tools gets called, or maybe it's a code invocation, or it can be a supply chain problem as well. And the next piece is the identity layer. Like whether someone is authorized to do this transaction, and in case of inter-agent kind of a deployment, if an agent is delegating a task to another agent, let's say A is delegating a task to agent B, then is agent B, is it supposed to execute all the actions on behalf of agents A's permission or agents B permission? These are some of the things which has to be explicitly defined. We should not let the agent decide like what to do. So these actions needs to be explicitly defined.
So, Vignesh, when you say these actions need to be explicitly defined, you are talking from the system prompt perspective or guardrail. Uh, what are we, where we need to define this?
Okay, yeah, that's a good question. So we have to so we should introduce a policy enforcement layer, so that layer should be capable of providing identity for all the agents. So now it's every agent should have an identity on its own, and then not just that identity. Just having an identity is not sufficient. We should also define like what is this agent supposed to do, what kind of tools it can call. Okay, when an agent delegates a task to other, like now the agent, let's say we have agent A and B. Now agent B should not just use the identity of agent A, it should use its own identity. So these are some of the enforcement layers that has to be in place in the agentic deployment. So yeah, the primitive ways to like the guardrails, of course, they're like very primitive, I would say, that can like handle prompt injection kind of an attacks. So these are like the enforcement layers that should happen after the LLM's output. So once we have an LLM's output, then there it decides like what is the next agent it should call, all that, right? So at that stage, we should have this enforcement layer. We should be capable of provisioning identity for all the agents, and then take decisions based on the authorization scope of the agent. All that has to be defined in the enforcement layer.
Okay, okay. Thanks, Vignesh.
Yeah. Um, Let me skip all this. Yeah, actually, so I was supposed to start from here, but then yeah, I had to start from the beginning. So based on all this, is maybe I planned for us a quiz here. So I just want you all guys to guess the number of tokens, okay? And yeah, I want to highlight maybe guessing the number of tokens. Every tokenizer will do it very differently. But here the idea is to just get a context about um, like different sentences will have a different number of tokens. So maybe the number of tokens may slightly vary based on the tokenizer, but the concept will still remain the same. So the here for this particular example, I'm using the GPT-4 tokenizer. I just want you all guys to guess, just take a guess, what could be the number of tokens for these sentences. Maybe the first one, the cat sat on the mat. Any guesses?
Seven. Seven.
Good. Good. 6 words and then one token for the full stop. The next one, many
It,
years, 20 years.
it'll be
One,
difficult. I mean,
one maybe.
Sorry?
I don't know. Maybe I'm just saying it's one token.
Okay. So, no, actually, since even though there's like same words, they will divide into like multiple tokens. So it can be like 3 or 4 based on the token.
it can combine any number of based on the tokenizer. It can
Yeah.
combine like either three eights as one token or four eights as one token.
Yeah, next one, maybe we need not guess the token, but I just
Multiple.
found it interesting. This is like a very big single word, supercalifragilisticexpialidocious. Anyways, I'll just
Eh,
reveal the answer for this is like 2 tokens. The next one, that is interesting. I love pizza so much, and this has some emojis.
Nine.
It would have consumed more, yeah, because of the emojis.
Nine
Yeah,
token.
yeah, you're near.
Okay.
Okay, I'll reveal the answer in the next slide. Maybe the next one is a Hindi. Namaste Dunya. It's a Hindi phrase.
Okay. See, I'll make a easy one. If I type Nanda, Nanda, okay, only one word. How many tokens? I'll not give this complex, right? Nanda. So how many tokens it consumes? Okay, somebody says five. Lakshmi says five. Who else wants to take a guess? Easy. It's a two token. Okay, go and check it out. There is a no, not one. There is a website called. Probably I'll share it. Share the link. You can try it out. Okay, go ahead, Vignesh. Sorry.
Okay, so this one, take a guess. So yeah, I'm not able to see your chat. Maybe whoever wants to take a guess, yeah. Please unmute yourself and speak.
So I think what Vignesh is doing this exercise is very important. When you want to be a hacker, it's not just text because LM sees everything as a tokens. You need to understand how token works. So I think this is part of that exercise. I've just gave you guys a link where you can put any word or sentence to understand based on which tokenizer it keeps splitting. Just try out my name, Nanda. You can put your name and then see whether it is considering as one word or multiple word. Why it is doing so. It is an interesting subject to understand. So it is going to be multiple. Yeah, Vignesh. I think. um I've not tried tokenizer on Hindi thing. I've not learned it, but
So,
obviously
okay, so the thing is, the other language, it takes like much more
more
tokens.
tokens.
Yeah, this is the answer. Actually, that Hindi sentence, like Namaste Dunya, just 2 words, but 21 tokens.
Okay, so check out that URL. It'll be really fun to learn how tokenizer works, and you should know about right from the bottom level how tokenization works, why it splits the word, and what are the different type of tokenizers are there. It is very important when you want to become a when you want to handle AI security. Sorry, Vishnu, please go.
Yeah, some understanding tokens is not just for a security, it's also for to maintain your finances as well. Or we are paying for tokens, right? So maybe if you're working in an enterprise, everything comes free. But if you have to do it in our personal settings, so then uh, We are paying for tokens, so it's important to understand how the tokens work and how to optimize that.
So Vignesh is speaking from the tech leader from Cisco budget.
Not just from as a tech leader, even if I have
As
to
a
like
developer.
use it for a personal purpose.
Yeah.
Okay.
So
The
just to understand, sorry.
yeah.
So just to understand how is the number of tokens actually getting determined? I did try out the link which Nanda shared.
Mm-hmm.
Sometimes it's breaking a word into three parts and considering it as three tokens. Sometimes if I give words, if I give a space, is the space getting considered as a token? How does it break this into number of tokens? The logic I wasn't quite able to figure out by trying it out.
Yeah, sure. That's a good question. So it actually differs from tokenizer to tokenizer. The same word in the very recent models, the number of tokens that number of tokens will be much more. Okay, so initially the way it design the how it worked is that maybe simple words, just the cat, they are all just one tokens. And if there is a comma, like if there are any punctuations, they are all counted separately. And then emojis, they take more tokens. So this is the general idea. Okay, but the recent tokenizers, right? That it still works on the same idea, but then they split much more aggressively. So that's why in a very recent tokenizers, the number of tokens that you would see, it'll be like slightly higher than this.
Okay, I'll just add a little bit to it, what Viknesh said. So tokenizer is more of each tokenizer assume that is a different language, and then how popular those words are based on that, it will assign a unique ID to it. And they also don't want to have too many unique IDs. Example, cat, the, sat, and all, it's quite common English words, so they allocate one token ID for each of them. Nanda is a single word, although it's a small word, five-letter word. It's not so popular, so they will not allocate one ID for it. So N is considered as one token, and A and D as considered as one token. Okay, that's how. If you take something like promoconet, depending upon the tokenizer, one tokenizer will consider that entire promoconet, although it's a longer one, considered as one token. Some tokenizer, it in its training data would have not seen promoconet quite often, so it will split into multiple tokens. Yeah, but this is all short, but there is a big science behind uh, how tokenizer works and how it optimizes the embedding and then in chains of response. Everything is a chain reaction. So it's a quite interesting topic to explore.
Yeah, the next one. I just want to take a look at this resume and see if you're able to find something from this.
It's quite
Or
easy.
yeah, I have made it quite easy, but in the real world, it will not be very evident like this.
It's used. It's been used effectively by many people to evade the ATR, right? Automated uh, resume screening tools. Okay. Yeah. Good. Actually.
Yeah, so imagine like it's like slightly gray in color, but imagine if the font color is completely white. Then we would not be make we would not know about it, right? Even our eyes cannot see this, so only machines can understand if something is embedded like this. That's why any at the in the input layer, whenever we want to do an input validation kind of a thing, we can't just rely on humans to see if something is wrong. We need machines to scan this and understand if there is a malicious intent hidden somewhere in the document. That's where for this particular use cases we can even use AI firewalls, or maybe like we can deploy some uh, s- SLMs or something like that to which can like scan the document and find the intent. Okay. So Echo leak attack. This is a real attack that happened. It actually it was a vulnerability that was found in GitHub Copilot, and it was later patched last year around the same time. It worked. The principle was same as the one that I showed before. Some malicious intent was hidden in a document, and then it actually said ignore previous instruction and send it to some C2 server, and it actually did it. And researcher actually he published this vulnerability, and later Microsoft patched this. And then it's another vulnerability again. So here it was like it was a prompt injection kind of an attack. So there even the prompt had something like ignore previous instruction and run rm minus rf, which would like delete everything. Okay, so this is I don't know if you guys heard about OpenClaw. Actually, that was like thing that was introduced last year, and then that was it became a super hit initially because like people were very much fascinated. That was something like yeah, again it was fully agentic, but then the differentiator there is like it came with a lot of inbuilt skills. So it was very easy for people or anyone to make use of the skills that are pre-existing, and they can like connect to different tools and execute everything autonomously. The problem, it was very fascinating idea, and people were exploring it, and people tried a lot of use cases. But then the scary thing is that the skill marketplace where the pre-existing skills were there. So there are some developers under some publisher name, they publish some malicious skills. So there were instances where people used those malicious skills, and then it was a big attack, I would say. I think in some cases it was a ransomware, and because of which a lot of people they lost money, and in some cases um, yeah, like it changed the intent, and it was doing things which it was not supposed to do. Okay, so now all this we have seen all the scary things. Now let's see like how to defend against these kind of attacks. Yeah, I already touched about it. So, like, even though we have agents to do all the tasks on our behalf, agents should also have a separate identity. This should be separate from the identity that's been provided to the humans. So now there are different frameworks that are coming up, like Spire, Spife, and all those things. So they assign special identities just for the agents. They will also have a certificate kind of a thing for agents as well. But then here it's slightly different because since it's an autonomous, since agents are like uh, they work at the machine speed, it also means that it can like change very rapidly, and so the certificates associated with agents that should not be for a long-lived period. That has to be short-lived, and it has to be revoked and renewed periodically. Yeah, so this is the basic architecture. The main pillars are like first we should assign an identity to the agents, and then the delegation context. So this is like when we have like multiple agents, and when agents delegate tasks to each other, then they should not be confused deputy problems. So that's something like in uh, so now the agent, the delegated agent. So what permissions should it use? So it has to use its own permission and its own identity, and then the scope the credentials. So this means that whenever you should assign tokens to the agents to perform a particular task. This token should also specify like what permissions it have, like what is the okay, what task can I perform. So the token should define all that, and it should also define that this is only for a particular period of time. Once this task is over, then the token should be revoked. And in case of multiple agents, they have to talk to each other. It's preferred to have a mutual TLS communication. That means both the uh, client and the server, it has to like verify its identity. And then the continuous recertification part that you talked about. So we should not let like we have seen for the traditional servers, they have around the certificate period would be like mostly like 2 to 3 years. But in case of agents, the certificate should be short-lived and it has to be renewed periodically. Yeah, it's just the same. I'll skip this. Yeah, now let's go to the policy architecture. So at a policy architecture level, so there should be like three types of policy. One is the governance policy. So that will define the compliance rules. Maybe it can be like an initial prompt filter kind of a thing. It can be like the guardrails that has to be set. And then these are some of the things that goes in as part of the governance policy. And the next one is the operational policies. Like this decides like what are the how to decide the tool permissions. Like we can use any kind of an identity providers for in this case. Actually, OAuth they provide a lot of identity frameworks specifically for agents. So the recent one is the OAuth 2, using which we can specifically define like, okay, using this token, what tools can be called and what should be the scope of action for this particular token. So all this can be defined. It can be any identity provider. OAuth is just an example. And the next thing is the runtime policies. So in case of agentic deployments, it's very important to like continuously monitor what the agents are trying to do. We should do a real-time monitoring, and then, based on the logs, we should also have a mechanism in place to do an anomaly kind of a detection. And once there is an anomaly detected, it's also very important to have a kill switch kind of a mechanism, which can like revoke the permission of the agents, and it can stop the agents from acting from that point. Yeah. So this is a very debatable topic, I would say. It's very difficult to say like how much autonomy we have to give to an agent. So this will depend based on the use case that we're trying to solve. So we should also be not too restrictive, because otherwise it defeats the purpose of agent. So in other if we make it like too restrictive, then there should be a human involved all the time to make sure that okay, uh, agent will ask for the permission of the human for any task, and the human should continuously monitor and give the permission. That will also like defeat the purpose of the agent, because it is losing its autonomous behavior there, right? So we should, based on the use case, we should decide as a team. Okay, so for what actions human approval is required? What are some of the actions that can be done by the agent itself without seeking for permissions? So these are some of the questions that we should ask. We should sit as a team and ask, and then frame the rules. So in case of a simple deployment, maybe if it's in case of, let me take an example of the cloud CLA or the cloud co-work. So there, some of these very important guardrails, they can go as part of the cloud settings file itself. Yeah, but if it's like a big agentic deployment, which involves like different tool calls that is not reversible, then a proper enforcement layer is required. The enforcement layer that should talk to identity providers, which can provide tokens with the scoped permissions. Yeah, so based on the use case, we have to decide like what kind of policy enforcement layer we should use. And full autonomy, yeah, of course, it's too permissive, so obviously it's dangerous. Yeah, the runtime monitoring. So I pretty much talked about it. So like, so as part of this runtime monitoring, every agents, all the communication between the agents, or be it agents to tool call, everything should be logged properly, and we should have a proper system which can do an anomaly detection based on the logs that we observe. Um, yeah, the kill switch is something that often people tend to ignore this, but this is very important, because once an anomaly is detected, we should have a way to contain that threat. Yeah, I'll skip this. This is pretty much what I talked about already. Yeah, so as a takeaway, I want to reiterate all these points. So first one is agent identity. That is something that is non-negotiable. Agent identity should be there because that's how we get to know like what agent did this particular task, or maybe this is the agent did this because it was told by a different agent. So there should be a way to monitor all these things, and so agent identity is non-negotiable. The next one is the tool security. So again, here we have to like validate what the tool is supposed to do, what is their input schema, output schema, description. We have to check the description to see if there is a malicious intent there. So yeah, so here the tool security layer, of course, this can be something which can be customized for a particular agentic deployment. Uh, so this can be as simple as like checking all the MCP tool cards and validating the description and the schema, or it can be even integrated as part of the policy enforcement layer itself. And the next one is the input validations. I can't stress more on this. This is very important. Like every input has to go through a validation layer, not just input, even the output also. It has to go through the validation layer to see if something is wrong, and to see if the prompt is intended to do some action which the model is not supposed to do. Again, here this can be like as simple as having simple guardrails set in maybe in case of a Claude, this can be set in the Claude's rules file as well, or else like if it involves a big agentic deployment, then we should have a separate kind of component like AI gateway for this. The next one is the memory security. Yeah, LLM has access to memory. So some of we should be very, the policies should be defined properly to make sure that which prompts should go to the long-term memory and which should go to the short-term memory. And if something is go to the short-term memory, then we should make sure that it gets cleared after after the particular interaction is complete, because we should not be leaking information between the two different kind of sessions. Yeah, human in the loop. This is very important because like we should not let the agent do everything on its own. For all the important decision points, we should have human in the loop to approve the action.
Vignesh, I have a question on that human in the loop.
Yeah,
How practical it is, because we are all using Cloud Code and other tools, right? And we sometimes I used to keep clicking okay, 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 and then the next is give the option to in these kind of actions, go ahead and do it. Now I do auto approve. I don't even sit and monitor. How practical it is, um, human in the loop, that at the scale of AI doing things for us. Um,
yeah.
y-
Yeah, I get it. Yeah, of course, it'll create a lot of fatigue if a human in the loop is involved for all the process.
Actions.
Yeah, all the actions, I would say. So, like for instance, for someone working on the cloud code, like there can be like multiple things. One is like going to checking the internet for some information. Yeah, checking the internet is only like you are reading something out of it, right? So maybe for that, human approval is not required. So maybe for actions like that, and anything which involves like just the read permission, maybe human approval is not required. So Claude has an option, like we have there is a settings.json file. So there we can define like for what particular actions approval is not required. So we can start with a bare minimal. Maybe as we work, we'll know like, okay, maybe for this, my approval is not required. So then we can add it to the settings.json. Again, this can be defined at a global account level, or it can be defined even at the project level. So maybe some permissions like maybe a web search, maybe that can be defined in the account level itself. And other project specific information that can be defined in the local project level settings.
Again, I
Yeah,
think
we can
the
start with the bare minimal, and as we work. Yeah,
at the
go
production
ahead.
level, sorry, at the production level, I had an opportunity to talk to the product manager of Flipkart, and they have nicely implemented AI agents would intervene in the call support for customer call support. And they had a very nice, as you raise a complaint, by the time you finish it, the agent gets collects all the information of your shipping, and then that where the items is in the transit, all the collects, and then it finds the your grievance, match it, and then prepares a response to you. Instead of giving that agent response, put the response back to the user, it gives that all the information plus the response, which is proposed by the AI agents to the human customer support. He or she
Mm.
will review based on her experience, and then once she approves, it goes to the user, the auto response. It's not an auto response. There, I think human in loop works perfectly fine, right? Instead of letting the AI agent automatically respond something to the end user,
Mm.
the experience agent, human person reviews what has been drafted and then it responded. But in the development, it'll be quite challenging, as you said, settings, and then hoops also can be used. I think
Yeah.
hoops has the option to do something before a tool or after the tool. I think there also.
Yeah, correct. So hooks is something like you can define like a uh, at a specific trigger that gets
Mm,
called, and there we can define the event that can be used for the guardrails. So before
mm,
any user input that goes to the model, then we can like invoke the hooks to check, i- i- and then we can see all if uh, if all the prompts, if they are right, and if they are not doing something which is not intended to do, yeah, of course we can write hooks that can be done before the input, I mean before at the input layer as well as the output layer. That is one option. And then for the permissions, yeah, settings.json, that is another option.
okay.
Yeah, one question I have initially. So, I know, like you're presenting security agentic framework. I think agent identity tool security input validation. So, so have you ever, I mean, explored any tools that does all, I mean, take care of all these five, the important thing that is required to control a complete agent? Is there any tool available in the market to do this all this
Yeah.
activity?
Yeah, very timely question. I'll come to it. Yeah, and then we talked about the guardrails, and in case of multi-agent security, we should make sure that the communication between the agents is secure. It should, yeah, very preliminary. It should not be plain text. It should be an encrypted communication, and if possible, it should be a mutual TLS communication. And yeah, the next one is the adversarial testing. So this is very important. Like whatever kind of like security framework that we come up with, right? There will always be hackers who are working on the other side who will be trying to see if there are any alternative ways to get into the system. So before they can reach the system, it's very important that we have an internal team which can do some red team kind of an exercise to find out if there is a possibility to breach into the system. Yeah, all the fuzzing tools with the agents, it has become even more easy, and there are a lot of AI-based fuzzing tools available, and then the AI tools available for red team exercise as well. So that is a very important step that should not be ignored. Yeah, and the last but not the least, it's a continuous monitoring part. Yeah, now who is executing the agentic era? Of course, like if it's a big enterprise kind of a deployment, then I would suggest that it's better to go with the solutions that are already existing, uh, because those are well tested and they are backed up by companies. So here I have listed just the prominent players here, but there are a lot of other startups who are working on this space and who have built tools for AI security. Uh, yeah, so to answer for your question, this will help only for a big enterprise kind of a setting. Yeah, But if it is for a personal project, or maybe if it's for a small projects, then it's not practically possible to buy those expensive tools, right? So there are also some of the open source tools that are available. Like Microsoft has one for the, it can like, it's called like an agent governance toolkit. So it covers all the OWASP agentic risk, and it can see if any of the possible risk vectors is there in the agentic deployment, and it can like point out that. And there are also other tools like Pipelog, Agent Mesh. I have not tried it out, but I have heard good reviews about these tools. And Cisco also has another open source tool called Cisco Defense Claw. So this is something like it can scan all the MCP existing MCP tools in the network, and it can also scan the skills, and it can check if the skills are proper registered ones, or it can flag if there is a malicious intent in some of the skills. And there is also called as an AI bomb. So we used to have software bill of materials, which kind of given a particular deployment, it can like scan all the different third party libraries used, the versions associated with that, and it can like say information about whether the particular version is vulnerable or not. So AI bomb is something similar to that, but it talks about the AI aspects of the deployment. So it's like what are the different models, whether they are all, if there is any vulnerable existing CV associated with that, what are the different tools used. So AI bomb is about that. And then this other one is the code guard. Code guard. And that's an effort wherein like you can give the complete code. It can give You can give access to your the code repository, and it can find out the code vulnerabilities present. It can be as simple as like maybe some security key is hard coded in the code. It can flag attacks like that, and it can be like memory leaks or attacks like that as well. Yeah, this is by Cisco itself. I have tried this, and it's very cool, and you guys can also try it out. And then coming to like evaluation and the guardrails, I have not tried all of these tools, but I have heard very good reviews of all these things. Yeah, so Inspect AI, and then there is also from NVIDIA, they have something called as a Nemo guardrails. From observability point of view, there is something called as a Langforce, which gives the LLM level observability, and it traces every call. Yeah, these are some of the open source options that are available that can be tried out initially, and maybe um, we can develop on top of it based on the requirements. Yeah. So safe autonomy is actually explicit boundaries, enforced policies, and continuous monitoring. It's actually all three. The key question is not to ask how intelligent our AI is, but it's actually how governable is our AI. Can you audit every decision? If there is an attack on you, is it possible to contain a failure? So the answer should be yes to all these questions. So otherwise, we are deploying agentic deployments in a not production ready way. So the agentic shift is right there. So the companies that will thrive will be the ones who embrace it with the proper controls. Um, yeah, maybe based out of fear, if the organization are not trying it, then again it's a loss for the organization. And on the other way, like if they expedite too much out of FOMO, if they like embrace this technology without proper controls, again that will be a very big disaster. So to reiterate, the organization will thrive this shift will be the ones who embrace it with proper controls. So every action should be boundary constrained, authorized, and monitored. Yeah, that's all I have. Thank you.
Thanks, Vigneshwari. That's a nice one on the last with the emoji or sorry, Jeff. Any questions from the audience? Cool. Okay, I think Vigneshwari, this is a wonderful session. In fact, that the few slides where you talked about some of the free tools and then the paid tools was really good. I also would like to try it out in some of the projects that I'm working on. Wonderful for the second session. I think same as the first one. We had a full people at attendance with nobody has dropped it. Wonderful. I think Raj has some questions.
Thank you, Vignesh.
Yeah.
It was a great session. I mean, thanks for giving some heads up on the last session as well. Because last session we didn't attend. I mean, thanks for giving some heads up on that as well.
Yeah, sure.
So
So I'd like to add, I mean, so there is a B-side conference happening in Bangalore next month, the 9th of July. So I'm actually part of the committee, organizing committee. So I have a coupon code. I'm just sharing it if anybody interested. So feel free to use it in the chat. I'm sharing it in the chat.
Oh, that's cool.
Yeah.
So Dinesh, I'll try to connect with you. Probably you can ping me.
Hmm.
Yeah, is the speaker session everything completed or as slots are there yet?
I need to check. I mean, so I can check with and let you know.
Sure, sure. Because I'd been speaking in the B-sides Agra, B-sides Chennai,
Hmm.
and I missed to uh, put it on the B-side Bangalore. Me and my wife co-presents.
Okay.
She's in Cisco. Anyway, we'll
Hmm.
connect
We
offline.
can connect. I mean,
Okay, thank you.
I'll get the details for you. Yeah.
Sure. So 45% discount is it?
Yeah.
I think people should try this out. Little bit of history about B-sides. Um, B-sides had formed just to ensure very good technical people get an opportunity to speak. RSA, well, this is, I think, came as a filler for RSA and the Black Hat. Black Hat and RSA are kind of a big legend. Only big speaker or reputed speakers keeps getting it. People who are very good and would very not get an opportunity. I think B-sides came into existence. The reason I'm saying it, if you attend B-sides in Chennai or Bangalore, these chapters are really good. You'll get to listen to speakers who are like veteran, but you don't see them in the RSA. But really good content you'll find it in B-sides. Okay.
Yeah, sure. Thanks for that, Dinesh.
Yeah.
I think there's one question Raj is asking, what we need to consider when we implement the AI agents for OT. Yeah, so OT kind of a protocol, that's when a lot of attacks happens because those are the environment like which most of the time it works with some constraints, right? Either there'll be like a space constraint, power constraint, and all that. So it's very easy to there's a tendency to easily skip the security aspects there, and even a lot of protocols by themselves um, have some vulnerabilities there. I just attended ACM CCS conference 2 weeks back, and even there is a lot of papers that have been published around like where they expose vulnerabilities in the protocol itself. In the OT protocols itself. Yeah, but that is one side of it. And the other side is that like if we implement agents there, then I would say like based on the constraints, at least we should have like the bare minimal guardrail setup. So the first one should be obviously the input layer, the guardrails, like wherein all the prompts should be filtered. So there, even if we lack the compute power within the OT environment itself, it should at least be talking to the cloud to make sure that the particular input is good enough to be fed into the model. So yeah, so a lot of times I understand that there will be compute kind of problems. So though there at least we should have like a cloud-based, we should do a cloud-based lookup to find out that uh, the particular input that's being fed is proper. And even for the output part, I think that yeah, the practical way to do it is that send out the logs. Obviously, it will be sending out, but then we should like monitor all the communications and then have a proper behavioral system setup, which can like absorb all the logs and then do an sim if not a SIM kind of a system, at least we should have a simple log analyzer kind of a system which can like track every actions.
Cool. Anything else? Any last questions to Vigneshwari? Okay. Thanks, Vigneshwari, for the wonderful session, and thanks everyone for being patient and then listening all this 1 hour session. Thank you. Thanks everyone. And we will post this recording in the YouTube channel and then share it on the WhatsApp groups. Thank
Yeah,
you all.
thanks, Nanda, for arranging it. I mean, it was a great session. Thank you.
Yeah, thank you everyone. Bye.